Hello everyone, I, Vedant Deshmukh and Ritik Ratnawat have created a project called Flight Fare Prediction. This project have been provided by Ineuron under their internship.
Hello everyone, myself Ritik Ratnawat. Currently, I am pursuing BTech in Computer Science with a specialization in Data Science. Today, I am here to demonstrate my newly built project, which is named as Flight Fare Prediction. So, let's start. This project basically predict the flight fare from a particular source to a destination. So, this is the web UI of that project. Here, when we click on the let's go, we are going to a page where we have to enter some of the details. That our first is the departure date when you have to go. So this is the departure date when you have to take a plane or flight from your source. So I am selecting it at 21 and the time is 10. 10:45, let's say. Okay, 10:57, that we selected, and the arrival when we have to reach is 2022 and the time is 7:54 p.m. Same. Okay, the source we have selected is Mumbai and the destination we have selected is Hyderabad. The flight airline ticket we have here select, let's see, Indigo, and the total stop we can see one stop. So here we have filled the details. When we click on the submit button, we can see that your flight fare from Mumbai to Hyderabad is rupees 5,349.41 paisa. So this is the approximate price prediction of that fare, which is when you take your flight from Mumbai to Hyderabad for the dates. Based on this ML model, it's working and giving us the predicted price. And at last, you can see our details of our developers that one of them. This is my profile. So this is how our project is working. So let's see some of the backend part in which we have further first do with the analysis and then we have deployed this. So the analysis part we can see later in the video. I am showing you how this backend is working. So here we have used the Flask framework using which we can develop a complete backend process and connect our ML model to that. So here we have see the create a function from welcome, and then for the predictor we have first to fetch all the details from the source like duration, total stop, and then pre-process it like our ML model want. So this our ML model is categorical data needs to be one hot encoded. So this all are one hot encoded and pre-processed, like which the ML model used to predict. Like this we have all, and at last here we can see that we have our model, which is we have imported using pickle to this file, and then using all the dimensions we have given to it and it's predicted. After that we round off and given this to our Flask framework, which helps to connect and display on our predictor page. So this is the thing we have used using the Jinja templates or Jinja tags. We have deployed this on the web page, and at last on the about us page we have seen that the details of the developers that are first of me and another one is Vedant. So this is all the backend processing, how this is working.
So you have seen how the project works and the front end of the project. Now let us have a look at how the ML model works. On your screen you can see the steps we have used to create this project. First, we have imported the libraries. Here we have used 4 libraries. Next, we import our dataset. You can see the first few rows of our dataset. For the pre-processing, first we have calculated the number of rows and columns in our dataset. Using .info function, we have checked for null values. You can see that there are some null values present, so we handle them. Using describe function, we have found out some information about our dataset. Next, for exploratory data analysis, we see that some columns, date of journey, duration, departure time, arrival time are of object type. So first we have to convert them into date time object for using them for our prediction. So first we convert date of journey column to date time. Then we separate it into separate columns, day and month. Similarly, we do for arrival time and departure time. We have distributed it into hour and minutes column for the each of the columns, and then we have dropped the initial columns. Next, for the duration column, we have used this function to convert the duration entries into minutes and create another column, duration minutes. As you can see here, duration minutes is created. Then we drop the initial duration column. For the categorical variables, we see that we have nominal data in our dataset. So we use one hot encoder. First, for source column, we first visualize the number of values that are present in the column. Next, we use one hot encoder to encode it. Similarly, for destination, the values are visualized and then encoded. And similarly, for airlines column also, the values are first visualized and then one hot encoded. Now, for route and total stops column, we notice that they are correlated. Therefore, in regression, we have to remove these correlated columns. So we drop the root column. For total stops column, we see that there are string values present, so we convert them into integer values. In additional info column, we see that more than 80% of the column is filled with no info, which will lead to bad results. So we drop this column. We have processed the training data. Next, we process the test data. We follow the same exact procedure for the test data. First, we calculate the number of rows and columns. Then we handle the missing values. Then we convert the object type columns to date time columns and then separate it into different columns. Similarly, date of journey, arrival time and departure time are processed. Then we used same function for converting the duration into duration minutes. Another column is created and then we drop the column. Now for handling the categorical variables, we again use one hot encoding on the source, destination and airline columns as we have done above. Then again we see that route and total stops are correlated. For the same reason, we drop the route column. Then for total stops column, we convert the string variables into integer type variables. Now, after that, we see that additional info again has no info for more than 80% of the values. That's why we drop this column. Then for feature selection, first we see that there are these are the columns that are present. Then we extract independent and dependent variables. First we create heat map to analyze relationship between different columns. Here is the heat map. Now we use extra-tree regressor to extract important features. Here are the proportions. Now we visualize the importances. We use three models: multiple linear regression, random forest regression, and decision tree regression. First, we do first we divide our dataset into training and test sets. Then, first we use multiple linear regression. The model is created and the values are predicted. Then we evaluate the model and calculate root mean squared error and R2 score for the multiple linear regression. Then we create random forest regression model. The model is fitted with values and the model predicts the values. Here are the predicted values, and after the evaluation we got two values, R2 score and root mean squared error. Then we create decision tree regression and the model is created, fitted and the values are predicted. After the evaluation, we again get those two values, root mean square error, R2 score. Analyzing the values for the three models, we can conclude that random forest regression is the best for the prediction, so we use that model. After that, we save the model using pickle library for future use. This is how the model is created and works in the backend. Thank you.